Hey guys, today we're going to talk about moles. While this isn't actually part of a review, I'm adding it in this section for two reasons. One, I want you to be comfortable with it when I introduce it later, so I want to do an easy part now. And two, because it can be set up in a similar way that we set up our conversion factors. And like I just said, while this unit is about reviewing past material or material you should already know, we are introducing this new unit of measurement because it directly relates to some of the math that we've already used. But right now it's just going to be an introduction. So a mole. A mole is a unit of measurement used in chemistry to express amounts of chemical substance. It is defined as the amount of substance that contains as many elementary entities, or atoms if they are individual atoms, so just copper or just lead, or molecules if we are looking at water as H2O. So it is the amount of substance that contains as many entities as there are atoms in 12 grams of pure carbon 12. So this dash 12 means that that carbon has a mass of 12 grams. So essentially it's a simplified number. Number of atoms of things can get ridiculously large, so we're going to be using times 10 to the something power. But just like we would say, I have a dozen eggs, we generally know that a dozen means 12. I can say I have 2 moles of substance, and 2 moles is 2 times 6.02 times 10 to the 23. So that's the unit. 1 mole is 6.022 times 10 to the 23 molecules of a compound or atoms of an element. So here's our conversion factor. 1 mole, 6.022 times 10 to the 23 parts. A mole is abbreviated using MOL, and no, I don't know why they only take one letter off. This can mean individual atoms if we are looking at an individual element, or bonded molecules if we are looking at a compound. And we use this just like we use other conversion factors from this unit. So we're going to set up our dimensional analysis, we are going to make our conversion factor fraction bars, multiply across the top, multiply across the bottom, and simplify. So here are some practice problems. How many moles are in the following? 10.3 times 10 to the 26 molecules. So just like in our earlier conversion practices, the number that I give you always goes over 1. Because that 1 is just our placeholder. In our second fraction bar, we have to set up in terms of what we want to disappear and what we want to stick around. So we are solving for how many moles are in the following. So I want moles to stick around and molecules to disappear. So since molecules is on the top of the fraction bar here, I want molecules on the bottom of the fraction bar over here. And that is 6.022 times 10 to the 23 is equal to 1 mole. So when I multiply across the top, I'm multiplying the 10.3 times 1, multiply across the bottom, I'm multiplying 1 times the 6.022, and that is going to leave me with 10.3 times 10 to the 26 over 6.022 times 10 to the 23. And then I just have to simplify that answer. And when we simplify that out, we are left with an answer of 1,710.4 moles. So we're going to do a similar problem again. 8.9 times 10 to the 52 molecules, and we're converting to moles. The number that I give you always goes over 1. In our new fraction bar, we have to set up molecules versus moles. So since we have molecules on the top and we want them to go away, we're going to put the 6.022 molecules on the bottom. And again, multiply across the top, multiply across the bottom, and that leaves us with 8.9 times 10 to the 52nd over 6.022 times 10 to the 23rd. And when we simplify that out, we have 1.47 times 10 to the 29 moles. Okay, so this is one way that we can convert molecules to moles. The next way is going back in the other direction. If I give you the number of moles, how many molecules are present? So again, the number I give you goes over 1, and we have to set up the second fraction bar based on what we want to stick around and what we want to go away. So we want moles to disappear, and we want to be left with molecules. So that means 1 mole goes on the bottom, because these are going to cancel. 6.022 times 10 to the 23rd molecules goes on the top. Instead of dividing here, in order to simplify, we're going to multiply across the top, and that's it. Because the bottom is 1 times 1, which equals 1. So 6.4 times 6.022 times 10 to the 23rd. And your answer is 8. And your answer is 3.85 times 10 to the 24th. And one more time, 1.5 moles is on the top, over 1. We want moles to go away, so 1 mole is on the bottom, and 6.022 times 10 to the 23 is on the top. We're going to multiply across the top. Our answer is 9.03 times 10 to the 23 molecules. Now, what a lot of people end up doing with these problems, you're used to typing in 6.022 times 10 caret 23. And that tends to be the buttons that people tend to press. In class, I'm going to show you a shortcut. Instead of using times 10 caret 23, we're going to use 2 capital E's, and it's going to replace this entire section. So the reason why we do that is because on the last slide when we divided, you're going to have order of operation errors if you simply type in times 10 caret 23 divided by something 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 times 10. Because your calculator is not as smart as you are, and they're going to do order of operations in a way that you don't necessarily intend. So when we get to class, I'm going to show you the shortcut of using the double E button in order to replace a times 10 caret. So when we get to class tomorrow, we're going to practice with converting with moles and molecules so we can then use it later in this year. So I'll talk to you guys soon.